The law of cosines is a great tool for finding missing sides and or angles if you know three sides or if you know two sides and the included angle, the angle between the two sides. So the way the law of cosines works is that you can take a side squared, and that equals the other two sides squared minus 2 times the value of those two sides times the cosine of the opposite angle. You see we have big and little a. Okay, so those are always going to be opposites. So I've written a couple variations, but let's write the equation for little c. So little c squared would equal the other two sides, with the squares, and then we take the sum, minus 2 times, we're going to do a times b, and then the cosine of angle c. So that's how that formula works. Now let's see if we can use the formula. Alrighty, so now we're looking to find angle, we know angle A, and now we want to find the side opposite. So what we do is we say a squared, because this would be our A, equals b squared plus c squared, that's the other two sides, minus 2 times those same two values, times the cosine of the opposite angle. So that would be 60. Now, the calculator is very, very friendly. We can take the cosine of both sides, and we get A equals the square root of 7 squared plus 2 squared minus 2 times 7 times 2 times the cosine of 60. And the calculator can handle all of that amazingly well. If you punch it in, and we're going to round to the nearest tenth, we get 6.2. And the units would be, this is a side, so that would be inches. So A is approximately 6.2 inches. Now, if we wanted to solve the entire triangle, we could proceed with the law of sines. And at this point, you would have an opposite pair to work with, and then you could find angle C and then angle B by making the angles add up to 180. Example 2, find the smallest angle. Now let's remember back to geometry. The smallest angle would be opposite the shortest side. So we're looking for this angle. And if you like, maybe you want to just put some labels on the triangle. So maybe we can call that angle C. And you can see here where I've already solved it, but I'm going to erase that and solve it along with you so that you can get a full understanding. So we're going to see if we can use, let's see, that's big C right there. So now we're going to say little c, which is 171 squared. Notice I went to the side opposite, equals the square of the other two sides. And I'm going to add those together because the formula is not really about A, B's, and C's. So I'm using 171 squared over here, so now I need the other two sides. And then the cosine of the opposite angle. That's our unknown. So now we need to get cosine of C alone. Okay, so we need to isolate that. So what I'm going to do first is I'm going to move I'm going to subtract this from both sides, and I'm also going to subtract this from both sides. And now that's going to leave me with all this stuff multiplied together. Now, I want to get cosine C by itself, so I'm going to divide both sides by -2 times 184 times 194 on both sides. So now that's gone from there. And on one side, all I have is cosine C. I'm going to move it over here to the left. I just like my unknown on the left. And then I have all of this on this side. Now, remember, we do the inverse function to get the C by itself. So now I have angle C is going to equal the inverse cosine of all this stuff. And believe it or not, the calculator, any good scientific calculator can handle this. So, very, very important that you pause the video and make sure that you can plug that in for yourself. So the measure of angle C, if you plug it in for yourself, you're going to find that that's about 53.9 degrees. 53.9 degrees is the measure of angle C, which is that smallest angle. We could proceed with the law of sines at this point. The law of sines, I think, is a little bit easier. And then we could find the measure of angle A or the measure of angle B. Let's do our last and final example. How far is the pitcher from first base? And we're going to round that to the nearest tenth. I want to tell you, in Major League Baseball, the bases are 90 feet apart, and the pitcher stands back 60.5 feet. So the pitcher is not lined up with first and third base, okay? Not quite. So we do not have a right triangle. And this is the value that we're looking for, the distance from the pitcher to first base. So now we can figure out this triangle right here. This is 90 feet, and that's our unknown. But we need to know an angle. And we can assume that the pitcher is standing straight back from home plate, which would divide this 90-degree angle in half. So that's a safe assumption. Let's blow this triangle up just a little bit so we can see it a little better. And that's not really drawn to scale, but close enough. And we want to find this value right here. So notice that we do have side angle side known, and we should be able to find that opposite side. So notice here we cannot use the law of sines because we don't know an opposite pair. So I'm going to go straight for law of cosines and say that x squared equals the other two sides squared. So that'll be 60.5 squared plus 90 squared minus 2 times those two sides times 90 times the cosine of 45. Okay, now I'm going to take the square root of both sides, and x is simply the square root of this. And again, your calculator should be able to handle all of that with no problem. But you do want to pause the video, practice, make sure that you can punch that in, because when you get to a test, you don't want to have calculator issues. That value, rounded to the nearest tenth, is about 63.7 feet. And remember, when you do a word problem, you do want to put it in context. So you might say the picture is 63.7 feet from first base.